Now we're going to fatigue failure resulting from various loading. Okay, so this one is a chapter 6 of the same books. Okay, what is fatigue? So we just go through very brief about fatigue first. Okay, now we go to introduction for the fatigues. In the stress strain diagram, the load normally is applied gradually and it gives enough time to the strain to fully develop. When you apply to the force to the specimens to test the condition of that, the stress is applied only once, then you take out. It's applied only once, so this one is we call static load applied condition. And the force that we apply is approximately to the actual conditions. But what if we apply it and then take out? Apply and take out. So this type of stress that we produce is a fatigue stress. So it's a variable, repeated, alternating of the fracture stress. Okay, but most of the machine part that fail, okay, because of the repeated of the fracturing stress happen to them. So we need to discover or investigate about this type of stress. This type of stress that is an actual maximum stress were well below the ultimate strength. That means the force, the stress that we apply is less than the ultimate strength and also below the yield strength. It's less than that, but it still feel. This one normally is going to feel when we apply it repeated with a very large number of time, used for some times below the ultimate strength or yield strength, then going to fail. This one is we call fatigue failure. When the machine part fail statically, apply the force field statically, it will develop a very large diffraction. Normally, very large diffraction when you apply once for the force, and then it exceed the yield strength. Okay, so this one is a normal stress condition. And before it's going to fail, we know that value, then we will replace it of the fracture before it can be happen. So to protect our parts. Okay, the whole machine is still can run because before fail, we can replace it, reduce the force. So it will give a visible warning in advance. But the condition for the fatigue failure is no warning. It's suddenly, it happens suddenly. So this one is very dangerous. And this phenomenon is complicated and is partially understood by the engineer or scientist until now. So we only can predict. Okay, we do some prediction and then we expect what is going on for that condition. When it's going to the fatigue failure, they will go through three parts. Stage one or more micro crack is start to be happen because of the cyclic plastic deformation. You apply and take out for the force, the stress. So it start to have micro crack that we can't see. This one still in stage one. In stage two, micro crack forming the parallel fractures. Okay, start to crack, cramming more and bigger crack. So it happens smooth and normal to the direction of the maximum tensor stress. Okay, how about stress 3? Stage 3, this happen is the final stress cycle, cannot support anymore, cannot support the load, and it happen very fast and fast fracture. It can be happen in brittle, ductile, or combination for both conditions. So this one is a photo for the stretch. Stage A propagates. Afterward, very fast fracture, and then go to C, fracture. Okay, so normally we will happen it in 3 stages. So fatigue failure is happen due to the crack formation and propagations. Okay, when it's going to be happen, when the design for the part, the hole, the keyways, you can find out is a rapid change in the cross section, stress concentration is happen. Second, high contact pressure. When you always make the part high contact pressure, even though it's less than the yield strength, and then it also can be happen and quite frequently happen. So another one is the poor design of the joint. The joint is poor design, so it also can be quite frequently happen for the fatigue failure. Besides that, there is a various other condition that can be make the crack initiation fast. Because of the tensile stress, evaluate temperature, corrosion of the environment, and high frequency cycling. And this one all happen in the localized area. So this one is the some pictures that is happen when fatigue failure and under high nominal stress or no low nominal stress. So high stress start to crack. After some time is directly fail. If low nominal stress is crack continuous until one condition is crack. So this one is faster. It's going to feel faster, suddenly happen because the high nominal stress. This one is low nominal stress. Okay.